So today we're going to be looking at Module 4, Lesson 18, where we're going to be finding the surface area of some right prisms. So for problem number 1, I want you to go ahead and start off like we did yesterday. It's going to be kind of difficult to create a net of this one, but they only want us to find the area of the lateral faces. So they want us to find all of the rectangles and find the area of those and put them together. So not the shapes that you see at the top or the bottom. Those are 1, 2, 3, 4, 5, 6-sided shapes. So those are hexagons. They do not want you to add those hexagons, just the rectangles around it. So I want you to go ahead and pause the video and find those shapes, or find the surface area of those on your own. So go ahead and pause the video now and hit restart when you have found your lateral area. All right, so as you can see here, I went ahead and created 6 boxes. We have a hexagon, a 6-sided shape as the base. So if the base has 6 sides, that means we have 6 lateral faces, all of rectangles if these are prisms. So I went ahead and just drew 6 rectangles. Now, obviously, they're not all the same size, but for me to be able to draw the net and be able to look at it, you can see that I went ahead and just created them all the same size. Now, if you notice, the lengths on every last one of these triangles all match up to the height of this prism, which is 15. So every last one of those long lines is a 15, which I wrote in red. And then I went ahead and color coordinated. So in red, the width of that first one right there on the left-hand side is a 3. And then in purple up at the top is 4. In orange is an 8. In yellow is a 6. In green, down at the bottom, is a 5. And then in blue is a 10. So then you just go ahead and do length times width, which I also color coordinate up at the top. So length times width, 3 times 15, 4 times 15, 8 times 15, 6 times 15, 5 times 15, and 10 times 15. Those are all 6 of my sides. I went ahead and multiplied all those numbers. Got 45, 60, 120, 90, 75, and 150. Added all of those areas of those lateral faces together and got our surface area of our total lateral area is 540 square centimeters. Now, what you may have noticed in the process of doing this is the more lateral faces you have, the longer it takes to do this. You also may have noticed, like we said, every single time that you tried to find the area of one of those lateral faces, it was always some number being multiplied by 15. So today we were going to learn a more efficient way to find the area of lateral faces. So we're going to be focusing on lateral faces today. And we will use that to find the surface area of some right prisms. So instead of drawing nets, we're going to be looking at how to use formulas to help us do that. So we're going to go ahead and take a look at problem number 2 and take a look at this together. So this process of number 2 is going to kind of set us up with an equation or a formula that's going to help us figure out the area of those lateral faces. So it says here that each of the right prisms has a height of h. And you can see each one of these figures, the height of that is actually an h. So every last one of those vertical lines are equal to h. So part A says to write an expression that represents the area of the lateral faces of the right triangular prism. So that is the first one that we're talking about. So if we're looking at the different rectangles, we have one rectangle right here. We'll do that one in blue. That one is going to be A times H, length times width. And we're going to go ahead and add that to our next rectangle, which is here, a B, and again the vertical line is an H. So that is going to be B times H. And then our last one is going to be the one that's in the front right here. And that one is going to be C times H. So C times H. Part B says to write an expression that represents the area of the lateral faces of the right rectangular prism. So if you notice, the triangular prism in A had 3 lateral faces. This rectangular prism is a rectangle. It's a quadrilateral, has 4 sides, so we're going to have 4 different faces to look at. So we have D and H. That's going to be right here in the front. So D times H, length times width, plus we also have in the back right here, remember rectangular prisms have opposites, that one is also D and H, so we have an extra DH, plus now we're talking about the left side and the right side, so we have right here on the right hand side in green, that is E times this height right here, which would be H. So E times H, plus the other side over here on the left hand side, we've got this one, also E times H. So there are 4 lateral sides for our rectangular prism. Now going ahead and taking care of our pentagonal prism. It says to write an expression that represents the area of the lateral faces of the right pentagonal prism. So, in doing that, we've got our first side right here. That one is V times the H. So V times H plus, after V, we're going to go ahead in alphabetical order. We have W right here in the front. W times H, length times width. Next, we have X right here. So X times H plus, the next one up is right over in the back. Right back here is going to be Y times H. And last but not least, all the way in the back is going to be our Z times H. So by multiplying the lengths and the widths of these rectangles, 3 rectangles for our triangular prism, 4 for our rectangular prism, and 5 for our pentagonal prism, you see that when we add these lengths and widths and add them all together, that is going to give us the area of all of the lateral faces, everything that is around, and pretty much most of the prism besides just the 2 bases that we have. So for part D, it says what measurement is used in each expression and why. And the measurement H is used in each expression because each prism has a height of H. So again, the measurement H is used in each expression because each prism has a height of H. So the variable H in each of these problems is a common factor. And we can use the distributive property to take care of and combine like terms. So that's what we're looking at in part E. So I'm going to go ahead and switch the screen to part E. So part E says to factor each expression. So we'll go ahead and take care of that. For our triangular prism, we had the expression A times H plus B times H plus C times H. So if we're going to factor out the H, that's going to be our common factor. We're going to take the H and put it on the outside of the parentheses in factored form. And the inside of the parentheses, we'll have A plus B plus C. For our rectangular prism, we had D times H plus E times H plus the other D times H plus the second E times h. Now we might not have had them in this particular order, but it's all the same thing. With addition, so we can swap them around. So then again, if we factor out the h, take the h out, put it outside the parentheses, what we're left with inside the parentheses is d plus e plus d plus e. And then the last one is our pentagonal. And for that one, we had v times h plus w times h plus x times h plus y times h plus z times h. And if we factor that h out, take the h out of all of those, divide it out. So vh divided by h is going to leave us with just a v. And then wh divided by h is going to leave us with w, and so on and so forth. So we have v, w, x, y, z. So those are all of those expressions that we came up with the h factored out. And part F says, actually, if we look at it, if we look at what's left inside the parentheses, so this ABC, this D plus E plus D plus E, this V plus W plus X, Y, Z, and you go back at the shapes. If I come back to these shapes, clear all of this stuff off, what we have left is A plus B plus C. When we add up all the sides, that is really the perimeter. Let's see if that's true on the rest of them. We had E plus D plus E plus D. Again, the perimeter. On the pentagon, we had V plus W plus X plus Y plus Z. So going back to these equations that we have over here, everything that I have boxed off in purple, what's in the parentheses is the perimeter of the bases. So that is the perimeter of one of the bases. A plus B plus C is the perimeter of the triangle. D plus E plus D plus E is the perimeter of one of those rectangles. And V plus W plus X plus Y plus Z is the perimeter of that pentagon. So looking at question F, it says describe how to find the area of lateral faces of any prism. So whether it's a triangular prism, a rectangular prism, pentagonal, hexagonal, octagonal, we can find the area of the lateral faces by multiplying the height of the prism by the perimeter of one of its bases. So writing that down, we can multiply the height of the prism by the perimeter of one of the bases. So we'll go ahead and take a look and see how can we use this new knowledge that we have now, which should make it a whole lot quicker to find the area of those lateral faces rather than having to draw 6 rectangles for a hexagon or 8 rectangles for an octagon. Let's go ahead and take a look and see how that can help us out finding the surface area of different shapes. So looking at number 3, it says to find the surface area of the right triangular prism. And I'm going to show you how to do this one. And I'm going to let you take care of the other ones on your own. And then we'll just come back to it and take a look at them. So first thing we need to do, if we want to find the surface area of these shapes, Yes, we're going to be looking for the lateral area in a second, but we need to take care of our bases first. So these particular bases have triangles. So the first thing we're going to do is we're going to find the area of the base. To abbreviate the area of the base, we use a capital B. B stands for the area of the base. So area of base. So we're going to find one of these triangles. Remember, the formula to find the area of a triangle is the base times the height divided by 2. We're going to go ahead and substitute those numbers in. The base of this triangle right here is 12 times our height, which you can find on this other identical triangle over here, which is an 8. And we're going to be dividing that by 2. So 12 times 8 gives us 96. And then 96 divided by 2 is going to give us 48. But remember that we have 2 bases. So we have 2 areas of our bases. So that means we're going to have to take 48, the area of one of those triangles, and multiply it times 2. And 48 times 2 is going to give us 96. So that is the area of both of our triangles. Now we can go ahead and use our new knowledge to find the area of our lateral faces. So if we want to talk about lateral faces, a good abbreviation would be LA, the lateral face area. So the area of the lateral faces. So we said the way that we do this is we have to multiply the height times the perimeter. So remember, these triangles are our bases, so they should technically be the things on the bottom. So you have to use your imagination and think about the triangles, one of these triangles being on the top and the other triangle being on the bottom. And if we did that, this would be the height of this entire prism right here, 16. So we learned that we need to take our height and multiply it times the perimeter of our base. So our height in this particular case is 16. And then if we add up the 3 sides of our triangle, we have a 12, a 12, a 10, and then on the other side right here, we don't have a number here, but if you look on the opposite side, it's another 10. So we're looking at 12 plus 10 plus 10. So that is 12 plus 10 plus 10. So if we add up everything that is inside those parentheses, that is going to give us 32. And then 16, the height of this entire prism, times the perimeter of our base is going to give us 512. And then after that, all we need to do is add up the area of our bases, both our bases, and the area of our lateral faces. Add those two numbers up. So 96 plus 512 is going to give us a total surface area of 608 square centimeters. So I don't know about you, but looking at how to solve these problems without a net and using these 2 equations, this looks a whole lot easier to me than having to find a whole bunch of different areas of a bunch of different shapes and adding them all together. So this is where we're going to let you take care of your own. So looking at problem number 4, just to kind of get you started, I want to first show you how you can find the area of a pentagon, even though we did one like this already the other day. Notice that they have the center of that base with a dot in it. So you can go ahead and draw some arrows and create yourself 5 different triangles for this pentagon. So right here, you find the area of one of those triangles and multiply it times 5. That's going to give you the area of one of your bases. And remember, you got 2 bases, and then use the same thing. The height of the prism times the perimeter of the bases. And this is a right regular pentagonal prism. So if you remember from yesterday what I told you a regular pentagon meant, a regular pentagon or a regular hexagon means that all the sides are equal length. So every one of those 5 sides is equal to 13.1. So go ahead and use what we just learned. Try it out on your own. See if you can come up with the surface area. Pause the video, and when you come back, I'll have it all taken care of and I can explain. All right, so here's my work that I did for number 4. The first thing that you see in green here was finding the area of my base. So we had 5 different triangles that made up that base down at the bottom. So I went ahead and did 5 times, and they were all triangles, base time height divided by 2. Then I went ahead and substituted my base, which was 13.1. My height was 9. 13.1 times 9 divided by 2 gave me 58.95. And I multiplied it times the 5 triangles. So just one triangle was equal to 58.95, and we had 5 of them. So that gave me one pentagon's area. One pentagon's area was 294.75. But we have the pentagon down here and the pentagon up here. So I went ahead and multiplied that one pentagon times 2 to get both of the pentagons, which was 589.5. So those are the area of my 2 bases. Then I went ahead and used what we learned today, finding the lateral area. So the height times the perimeter of the base. My height is 18 of my prism. And then I went ahead and said, well, if this is a regular pentagon, each one of these sides is equal to 13.1. So that's 5 sides that are equal to 13.1. So to find the perimeter, I just multiplied 5 sides times 13.1 and got 65.5. Then multiplied it times my height, and that's how I got 1,179. Taking those 2 numbers and adding them together, the area of both of my bases, and then my lateral face area, added those together to get the area of my entire pentagonal prism of 1,768.5. And they don't tell me any units on there, so I'm just going to go ahead and put units squared on the end. Taking a look at problem number 5. So this is a right trapezoidal prism. Now you can see that there's a rectangle at the top and a rectangle at the bottom, but when the trapezoid they're talking about as the base is this trapezoid right here in the front, and then the other trapezoid is right back here in the back. So those are technically our bases. And if you look at all the other pieces, it's a bunch of rectangles all the way around it. So there's a rectangle here, a rectangle here, a rectangle down here sitting on the bottom, and then a rectangle right over here. This trapezoid has 4 sides, so therefore we have 4 lateral faces. Just because this is a new shape doesn't mean it's not done the same exact way. So find the area of one of those trapezoids. Again, we're going to have to use decomposition because there's no formula to find the area of a trapezoid. So find the area of one of those bases, multiply it times 2 because you have 2 bases, and then use the lateral area formula, height times the perimeter of the base. And go ahead and add them together, get your total surface area. So pause the video and take care of that. All right, so looking at this problem, the first thing we need to figure out is what is the area of our base. So we're looking at the trapezoid. That trapezoid can be split into 2 different shapes. We have a rectangle here in red, and then to the side of it, it would be this right triangle right here. So I went ahead and wrote down the area of my base is equal to formula for a rectangle, length time width, plus the formula for a triangle, base time height divided by 2. Then I need to figure out what my lengths and widths were. So one of them was pretty obvious right here on my rectangle. Let me use my highlighter instead. So that was 2.3. But then this entire bottom line that includes the rectangle and the triangle is 2.9. So I had to figure out what was each piece. So if I just want the piece in red, if you look on the opposite side up here, that red line doesn't have a number. But if you look on the opposite side of this rectangle, it shows me that that piece is 2. So from here to here was 2. If that piece is 2, but the whole thing is 2.9, that must mean that the base of this triangle is 0.9. And then the only other thing I needed, so that's my 2 numbers for my rectangle, 2.3 times 2, that's my length times my width. And then for the triangle, my base is 0.9, and my height right here is, look, the opposite of the rectangle, 2.3. So that's how I got those numbers for those formulas there that you see. So then I went ahead and just multiplied that. 2.3 times 2 is 4.6. 0.9 times 2.3 divided by 2 is 1.035. Take that rectangle and that triangle, put it together, and that gives you the area of one of those trapezoids, 5.635. But remember, we have 2 trapezoids, so we have to multiply it times 2, and we get 11.27. That is the area of our 2 bases. Then we have to worry about our lateral faces. So remember, your bases, you have to use your imagination. Those trapezoids should be laying on the ground. So that means if you got it laying on the ground, this 1 meter right here would actually be your height. That'd be how tall this prism is. So that's why I put a 1 in for my height. Then I have to figure out the perimeter of my base. So I just go around one of the trapezoids. We've got 2.3 right here. Right here we got 2.9. Up here there is no number, but if you look across, it's right there, 2.47. And again, this side right here, you have to look across the other side and you see a 2. So those are my numbers, the lengths of my sides to find my perimeter. You add all those numbers up together, you get 9.67. Obviously times the height of 1 would keep it at 9.67. And then you go ahead and you add up the area of your bases, then your lateral area to get your grand total. The surface area of this trapezoidal prism is 20.94 meters squared. And our last problem is problem 6, and it gives us a little word problem. Eve has a fish tank shaped like a right regular hexagonal prism. So the right means that all of our lateral faces are right angle triangles. The regular means that the hexagon all has the same length. Every side is the same length. So her fish tank does not have a top. So the top is not there. So that means we only have one base to worry about this time. It's the base on the bottom. The other faces are glass. Find the area of the glass of her fish tank. The line segment labeled 9.1 inches begins at the center of the hexagon and ends at one side of the hexagon. So that's just telling you how you need to separate it to find your area of your base. You do the same thing, create a bunch of triangles, multiply by how many triangles you're going to have. This is a hexagon, a 6-sided shape, so you should have 6 sides. So again, pause the video, go ahead and take a look at it. Remember, this time you only have one base. That top is open to put water and fish in. Go ahead and pause the video now. All right, so taking a look at this particular problem, looking at the bottom base down here, I went ahead and split it into 6 different same size identical triangles. All 6 of those triangles had a base of 10.5 and a height of 9.1, which I plugged into my formula right here. Each triangle has an area of 47.775, and I multiplied it times 6 because we have 6 triangles. So the area of that one pentagon is 286.65. We do not have to multiply it times 2 because the story tells us that the top is not there. Then we have to worry about the lateral area. So it's the height times the perimeter of the base. The height is 24. There are 6 sides because this is a regular hexagon. And because it's a regular hexagon, each side is equal at 10.5. So the 6 sides at 10.5 gives us a perimeter of 63. We multiply that times the height of 24. We get an area of all of our surface, our lateral faces are 1,512. So we take our area of our one base, plus the area of all our lateral faces, add them together, and get our final surface area of 1,798.65 inches squared. So that is it for this particular lesson. You can go ahead and take a look at the exit ticket. If you're not in the class with me, if you're in the class with me, if you have any questions, come and find me, come ask them. We can work on our exit ticket, get that taken care of. If you need some practice problems, because it's not going to hurt to practice, we can do some of those. iReady, different things like that until our time is used up if you're not in the class with me. And have a good weekend.